but I hope we are all here. And my name is Mikael Durking. I am Executive Secretary at Coalition Clean Baltic. And I can present our organization a little bit later when we have time for that. But now it's officially 12, so we can start. So very welcome to all of you to this event here in Riga. I am happy that it is already, I think, a second or third event of this kind when it is a very good cooperation between HELCOM and HELCOM observers. So not only the contracting parties, but also HELCOM observers who are supporting the work on specific issues related to implementation of the Baltic Sea Action Plan. But of course, to open the workshop, we should really give the welcome words to our co-organizing, co-hosting countries. And I don't know, maybe Laura wanted to rush directly to say something on behalf of Latvia, or we still have other countries, so if you wish to live for a while, then we can perhaps pass to Sweden first. Whom do we have from Sweden to welcome? Yes, good.
A few words, yes. Okay. Well, thank you. My name is Fredrik Lindgren. I represent the Swedish Agency for Marine and Water Management. And it's very nice to see a lot of people here today to discuss this topic with tank cleanings from shipping. We have seen a problem with this nationally for a number of years now. We have also a group who's working with this, since we have also a measure nationally concerning this within the Marine Framework Directive. So in Sweden we have a group that's working with this from my agency, from the Coastguard, from the Swedish Transport Agency, and from Havsmiljöinstitutet. What's that in English, Eva-Lotta? The Swedish Institute for Marine Environment. So we are very happy to see a lot of people here today, which is going to discuss this topic, and we look for fruitful discussions today and tomorrow. Thank you.
Super, thank you. Thanks a lot, Fredrik. And then we have Jyrki Vähäralo from Transport Administration in Finland, who will also welcome on behalf of Finland.
Yeah, thanks, Misa, and yes, and colleagues and friends and so on. I think on the behalf of Finland, I wish you all, of course, warmly welcome in person here, or also online participants to this first workshop. This very nice city, Riga, you know, and I think this is the first time that we joined together to start our collaboration with this issue of MARPOL Annex 2. And as you say that we have all, I think I work very closely with our Finnish MARPOL surveyors, and almost every week we have some problems. Tomorrow I will have my presentation, I will go deeply for that. And remember that we have our common goal, that is Baltic Sea Action Plan S60. So this is, I think, more or less that we start together. How do we continue with this? And as you know that there are not countless number of chemicals carried by chemical tankers, but let's say very many different kind of chemicals. And discharge every day in various ports of Baltic Sea. And as you know that many of these chemicals present hazard to the marine environment and human health based on their classification. So I think that we have very good presentation from Matthias to how this classification process will be done by GESAMP EHS group. And I have this anecdote, perhaps two anecdotes, that one of the most dangerous chemicals are dihydrogen monoxide that is carried. And just another one is that even these chemicals can be beneficial to the Baltic Sea. For example, with low amounts and diluted concentration. And for example, this is caustic soda, sodium hydroxide solution. So there are so many different chemicals with different chemical physical properties, so we have to be perhaps category Y substances quite careful what we do in the future. Of course, finally, I would like to thank the organizers, all organizers here, and I'm looking forward to have a very successful and fruitful discussion and workshop here in Riga. So, thanks, Mita.
Thank you very much, Jyrki, and now Laura, it's your turn. And you can use either that mic or this one.
Thank you. Yeah. My name is Laura Mazmač, and I'm from State Environmental Service from Latvia, and also work as a representative from Latvia in HELCOM Maritime and Response working groups. So actually, everything I wanted to tell was told about by previous speakers. So just I'm happy to see everyone here in Riga and also online. And as it was told, it is first meeting regarding this issue, and I hope we will find some very useful solutions and possible ideas to implement in future and to save our sea more. Thank you. That's it.
Thank you very much, Laura. Indeed, this is all very relevant and important, and thanks for this kind welcoming words. I hope that we have Susanne Heidmöller also online with us. And Susanne, for those of you who don't know, she is the chair of HELCOM Maritime Group. So Susanne, the floor is yours.
Wow, and I see me on the big screen. Wow. Hello, everyone, and also very warm welcome from my side as the chair of the Maritime Working Group. And I have to say that I'm also very, very pleased about this workshop, and I want to thank particularly our hosts of the workshop. So this, how do you say, like a trio of contracting parties, Sweden, Finland and Latvia. Thank you so much. And then also with the great support of the John Nurminen Foundation and CCB. So thank you very much for organizing this event. I think it's really important that we address this issue. And I very much also trust that we will have very good deliberations in front of us, as we have a kind of a very good basis, as we had like with Finland and Sweden, which have already contributed to this work quite well, substantially, and had also at the last Maritime Working Group submitted very interesting documents and studies. So we have a very good basis that we can start off. And I very much also hope that this will be taken up by other contracting parties as an inspiration. So, and it's kind of easy for us now to start our work, as we can learn a lot, I guess, in the next 2 days and take it then from there. So I'm very confident that the implementation of the S16 of the Baltic Sea Action Plan is on track. And thank you very much for all the work already that has been done. And I wish you all very fruitful discussions and good deliberations and a wonderful time in Riga. So, and I will also attend this workshop now and during the next days, unfortunately only online, but I'm very interested to learn and to hear from all of you. So thank you very much.
Very much, Susanne. So then, without any further delay, we have quite busy agenda for those 2 days now, and we will start with some introductory presentations about what the topic is, in order to be on the same page, all of us. So for setting the scene, and then after coffee break we will continue with the further, well, I still would say setting the scene type of presentations about particularly the tank cleaning and tank wash water and how it impacts the environment, and also about the real impacts in the environment, what we can see and what we can witness. And after that, before wrapping up for today, which is expected by probably 4 o'clock, we will have further more practical examples on how to deal with decreasing discharges in cooperation with the industry. So that is the program for today. And tomorrow we will have more of a workshop type of discussion, starting with the tour de table among the HELCOM contracting parties, among the countries, sharing their experiences, and we still hope that more countries will join in this round. We'll have some dedicated also presentations, particularly from Finland and Sweden as the leads in this work so far. And then after the coffee break, we will have really a workshop talking about specific issues that we think are important for moving forward the implementation of this action of the Baltic Sea Action Plan. And expected to close by 12. I'm quite sure that many of you would wish to get back home in Finland in time. From here in time. Not necessarily to Finland, but many other places. Okay, so now I think it's good time for passing the floor to Markus Helavuori, the professional secretary from HELCOM Secretariat, to talk about the Baltic Sea Action Plan and particularly the commitments related to reducing impacts of hazardous substances from shipping in this particular case, I guess.
Yes, thank you very much, Misha, and thank you also on behalf of the HELCOM Secretariat to Latvia, Sweden and Finland for hosting this, and especially to CCB and John Nurminen Foundation for actually making it happen. Your support is really, really important for us because we have a lot of meetings, working groups, expert groups, actions, workshops, and it really, really makes it easier to organize these kinds of events to implement or further the implementation of various commitments with your very valuable support. So thank you very much for that. So yes, I will talk a little bit about now, first an introduction to HELCOM, because maybe not all of you are that familiar with what HELCOM is and how it works. But then a few words about the Baltic Sea Action Plan and a particular focus on Action S16, which is the one we are here for today and tomorrow. So, and actually maybe I should have made a slightly longer introduction to what HELCOM is, because I didn't realize that there are actually quite few of the not typical HELCOM workshop or meeting participants here. But in brief, HELCOM is an intergovernmental organization. It's based on an international convention, the Helsinki Convention, which is a legally binding instrument of international law. And the main objective is, of course, the protection of the Baltic Sea environment from various human pressures. The convention was signed already in 1974, so this year we are celebrating 50 years, and we actually did it 2 or was it 3 weeks ago here in Riga, not too far from here, and I know some of you were there as well. So we had a very nice celebration following the HELCOM ministerial meeting and HELCOM annual meeting. And of course, the reason why it was in Riga is that Latvia is currently the HELCOM chair country, still for about a month and a half, then Lithuania will take over. So yes, it's an intergovernmental organization. We have 10 contracting parties, all the Baltic Sea coastal states, and also the European Union is one of our contracting parties. So I represent the HELCOM Secretariat. We are there to support the work of the countries, to coordinate things, to organize meetings, workshops, and other events, to keep track of how various commitments are being implemented and followed. and to support the contracting parties in doing so. But all the decisions are always made by the contracting parties. This is important to remember. The HELCOM Secretariat is there to help, but the countries are HELCOM. So just a couple of words about our structure. We have a number of expert groups and like subgroups to the main working groups. This is where most of the work is done, and decisions and various instruments are being prepared for approval by the higher levels, which are heads of delegation, or HOD. They meet twice a year. And then we have the HELCOM annual Helsinki Commission meetings, which meet once a year. And that's the highest decision-making body, which is able then to adopt, for instance, new HELCOM recommendations and other instruments. And in addition, we also organize ministerial meetings roughly every 3 years. So this is also what happened here in Riga just a few weeks ago. So I mentioned the Helsinki Convention already. That's of course the most important instrument we're working with. All the contracting parties have ratified it. It's part of their national law that they have to follow, and it includes various provisions for the protection of the Baltic Sea from various pressures, chemicals and agriculture and shipping and making sure that oil pollution prevention response is in place, and etc. But in addition to that, we have recommendations. Although that's soft law, that's still quite a strong commitment, and typically contracting parties implement the recommendations in their national legislation, making them actually binding for themselves. So this is a very important tool we have. In addition, we adopt various action plans, such as the regional action plans on marine litter, regional action plan on underwater noise, the Baltic Sea Action Plan, of course. I'll come back to that soon. And we also have one thing that's actually not mentioned here, guidelines and different guidance documents to help understand and implement various commitments, HELCOM commitments or commitments that the countries have committed to in other bodies, such as other international conventions. And now, since we are talking about shipping here, IMO conventions, for instance, we have a lot of recommendations that are focusing on a harmonized implementation of IMO measures within the Baltic Sea. HELCOM also works quite a lot on monitoring and assessment. It's our decision-making process is science-based. We want to be aware of the pressures and impacts on the Baltic Sea and what the solutions to address those could be. And in that work, of course, monitoring and assessing the state of the Baltic Sea is crucial. And on this note, I can mention that the third HELCOM holistic assessment was published last year and is quite a useful source of information about all the different components in the Baltic Sea environment and its current state. And this is something that we use to also then keep track of how effective the measures we have committed to and are implementing are in improving the state of the Baltic Sea. And then also ministerial meetings at more strategic level, goals and commitments on what should be achieved within HELCOM. So the Baltic Sea Action Plan has come up already a few times. This is a high-level commitment on the political level adopted by the HELCOM ministerial meeting in October 2021 in Lübeck, Germany. And it contains 199 actions, to be precise, on various topics. And in addition to that, the ministerial meeting actually also updated or adopted the regional action plan on marine litter and underwater noise, and also some other associated documents. So it's not only the Baltic Sea Action Plan, but this is the main sort of tool that we are working on in HELCOM now, with the overall objective of reaching good environmental status in the Baltic Sea. The aim is to implement all the actions in the Baltic Sea Action Plan at the latest by 2030. And as mentioned already, it's science-based. There was quite a lot of background work and preparatory work in developing the Baltic Sea Action Plan based on previous actions in the original 2007 Baltic Sea Action Plan that had not yet been committed, or other, it jumped already, but or other issues that were not yet addressed within HELCOM, and a lot of assessments were done also to get a better understanding of what actions and measures are needed in order to actually reach a good environmental status in the Baltic Sea. But in the end, of course, it's, adopting something like this is a negotiation among or between the contracting parties. Some actions that some country or some organization may have wanted to see in the Baltic Sea Action Plan was maybe not agreed by others, and therefore it might not be there, and others may have been, developed into a way which is acceptable to all. But the overall issue is still that all actions aim to be measurable, have clear targets. Actually, I think that comes on the next. No, it comes a bit later. Have clear targets so that we can actually determine later on when we have implemented them successfully, and this is to have an easier follow-up of how successful our work is within HELCOM, and also how it impacts the state of the Baltic Sea. So we want a healthy and resilient Baltic Sea ecosystem, and we have in the Baltic Sea Action Plan a number of segments. One on hazardous substances and litter, one on environmentally sustainable sea-based activities, and then Baltic Sea unaffected by eutrophication, and then also a number of horizontal topics. So although the hazardous substances and litter segment contains a lot of actions on hazardous substances, obviously this is not the focus of our workshop here now, but we are under the maritime activity, sea-based activity segment, which is also addressing then maritime related issues. So there is quite a lot of overlap, as also illustrated by this picture. They're not like completely separated from each other. Therefore also the work on implementing the action is not in all cases like determined to be under one specific HELCOM working group, but there is also a need for quite a lot of cooperation and coordination between various HELCOM groups in implementing a lot of the actions. So the overall aim is to implement all actions in the Baltic Sea Action Plan by 2030 at the latest, but all individual actions also have individual target dates for when they should be implementing. So they are not all to be done by 2030. They are spread out fairly evenly from starting in I think 2023, 24 are some of the earliest ones, and then stretching all the way to 2030 for some of the actions. All actions have at least one HELCOM body, such as a HELCOM working group or expert group, which has the sort of overseeing role in ensuring that the action is being implemented. Some of the actions are national, so it is the responsibility of individual contracting parties to implement them, but many of the actions are joint, and therefore some joint measures within HELCOM as a whole are needed in order to actually fulfill the aims in that specific action. And as mentioned earlier, there are for each action specific criteria which help us determine like what we should do to implement the action, and also to later on determine when it has been implemented. And we are tracking the implementation in an online tool called the HELCOM Explorer. There is already information there about implementation of some of the actions, but of course it's still fairly early days and not many actions have been completed yet, but some have. And this is a convenient place for anyone with an internet connection to find out like where we are with the implementation. And then of course the HELCOM monitoring programs and other assessment work that we are doing on a regular basis will also then try to establish like what the effects of implementation of the actions have been on the marine environment of the Baltic Sea. Now we come to action S16. So this is the topic for our workshop, and it reads in full: to carry out a study and impact assessment by 2026 to estimate and evaluate the volumes and impact of discharges or of residues of noxious liquid substances contained in cargo tank washing waters under the MARPOL Convention Annex 2 into the Baltic Sea. And based on the results, take relevant action by 2028 on whether and how to further limit discharges of residues of noxious liquid substances contained in cargo tank washing waters under MARPOL Annex 2 to the Baltic Sea. Now, I know you have not learned it by heart just by looking at this or hearing me read it out, so let's take it again a bit and break it down a little bit. The action consists of two main parts, which both should be implemented or like completed so that we have actually achieved what we are aiming for with this action. First of all, we should evaluate the volumes and impact of discharges from this tank washing waters under MARPOL Annex 2 in the Baltic Sea. And I'm sure we will hear much more about this later, but work is already ongoing and has been done in some countries already. We do have a general understanding of the scope of the issue and the impacts, but this is also one thing that we will surely discuss. That do we know enough? Do we still need more information? Are we, there in terms of facts so that we can actually take action? And that brings us to the second part of the action, which is of course the more concrete measure, and it's to take relevant action by 2028 on whether and how to further limit discharges of residues of noxious liquid substances contained in cargo tank washing waters under MARPOL Annex 2 into the Baltic Sea. So this is then where we, based on the science, the knowledge that we have about the substances, amounts and impacts, should make a decision on how we should address it. Should we, is there a need to address it? If so, what should the measure be? A HELCOM recommendation, a guideline, work among HELCOM contracting parties within IMO to amend MARPOL Annex 2, or something else. There could be many different options, and this is part of the work in implementing this action, and this is something that we will also discuss at this workshop. Like what options do we have? What would be a good option? And the overall aim with the action is of course to reduce the discharges of noxious liquid substances into the Baltic Sea. So this is something to keep in mind. This is what we want to achieve by this action. The action is under the responsibility of the HELCOM Maritime Working Group, and Finland has kindly offered to take the lead of implementing this action, and also Sweden very kindly has offered to co-lead the work from this year onwards. So thank you very much for both of the commitments from Finland and Sweden on this, and also of course for agreeing to be part of hosting this workshop. We have started discussing this action in the HELCOM Maritime Working Group. These are just some main points from the most recent session of the HELCOM Maritime Working Group held in October last year. There were 2 documents submitted to that session on this particular action. one by Sweden and another joint one by Finland, John Nurminen Foundation and CCB. I'm not going to go through the details of those now because a lot of the same things will come up at this workshop at a later stage. But just to summarize very briefly, there is already some work that has been done in particular Finland and Sweden, but maybe also some other countries, risk assessment studies, reports. We need to consider what else we need. Should we try to get similar work to be done in other contracting parties as well, or other countries in the Baltic Sea? We need to keep an eye on and be very much aware of what is going on within IMO, both at the MEPC and PPR on this topic. And then we need to figure out, like, should the approaches to address this problem be considered on the national level, or should we develop a draft common approach on what to do? And this is maybe more about the still, studying and assessing the impacts of the wash waters. But then we come to instruments. Should we aim towards amending the relevant IMO instruments, or should we work on Baltic Sea measures? So this is another thing to be discussed. And the Maritime Working Group also at its previous session recommended that a workshop should be organized to advance the implementation of Action S16. And this is that workshop. So now I hope we will have a very good and productive discussion. I have promised to take some notes and draft a memo so that we have something to report back to the Maritime Working Group on the basis of our discussions at this session. And hopefully it will be really useful in taking the implementation of this action to the next steps. So that's it from me, and if you have any questions or comments, I'd be happy to answer or discuss.
Thank you very much, Markus. And we have time actually for short questions, either from offline or online audience. I hope that you've got a little bit more of deeper detail into the Baltic Sea Action Plan and HELCOM process in general. Any questions? No? Yes, Jyrki?
I hope that this is not just one question. How is now HELCOM working? Because we know that there is something, some countries not participating. So please give me some words of how is HELCOM working without one country?
Yes. So, as I'm sure most of you are aware, one of the HELCOM contracting parties is currently not participating fully in HELCOM work. After the events that started in February 2022, all the other contracting parties jointly agreed that they are not willing to continue working as normal with Russia. And therefore, all formal or official HELCOM meetings have been suspended until further notice. So what we do instead is organizing informal consultation session. That's what the IC stands for, also in the code name for this workshop, and IC Maritime 2 that we had in October last year, informal consultation session of the Maritime Working Group. So Russia has not been invited to any HELCOM meetings since February 2022. But this doesn't mean that we have stopped working. So we are organizing meetings, workshops, etc. as before, but just without Russia present. Instead, and because of the HELCOM rules of procedures stating that decisions should be taken unanimously, Russia does have, because they are still a contracting party to HELCOM, they have the right to be part of decisions that are made in HELCOM. And therefore, any decisions that we want to make when they have been agreed within a working group or head of delegation or somewhere, they are recommended for approval or adoption or whatever the case may be, and then sent out for a formal approval or adoption procedure by correspondence instead. And in this process, Russia is also included. And in addition, technical work has been agreed to that it should continue. So for instance, when the HELCOM Secretariat requests data for some assessments that we are doing or other work where we need to get information from all the countries about, for instance, discharges or the state of the sea in a particular area or whatever the case may be, we do request this from Russia as before, and I would say that in most cases they do still provide also these kinds of information. So the cooperation has not completely stopped, but we are not organizing formal HELCOM meetings with Russia on board. So hopefully this clarifies it.
Yeah, thank you, Markus, for this clarification and once again for this comprehensive presentation.
Thank you.
So we can move on, and then I would like to invite Matthias Grote, who is representing the Federal Institute for Risk Assessment in Germany. And Matthias is also a member of the GESHAMP expert group on hazardous substances. And he will talk about current regulations regarding tank washing in the Baltic Sea within MARPOL convention, I guess.
Thank you for this introduction, and thank you for the invitation, which was a step because Julia contacted the IMO Secretariat whether they could participate. And as this week there is this meeting of the GESAM working group for evaluation of hazardous substances, but as they don't have the time to present, but they asked whether I would be willing to do this instead. And we were lucky because we have now in this GESAM working group 1 year we have online consultation, and the next year we have in-person meeting in London. So this time we have this remote meeting, which allows me that I could be here and on tomorrow afternoon still take part remotely in this meeting of the GESAM working group. So this is really good. So what I want to present today is, first of all, give you some overview about the MARPOL Convention, then how the categorization of noxious liquid substances is performed. The short is NLS. Sometimes I'm not sure how many times I will use this acronym, so just be prepared for this. Then I go into the discharge provisions, which are currently in place for these kind of cargoes. Then I will explain a little bit about cleaning agents, cleaning additives, because this is something which is also released from tank washing sometimes. So to give you some overview on this kind of compounds which may be present in discharges. Then I will present some new discharge provisions for solidifying substances, which has been agreed a few years ago and which is in force now. And then, as I'm not a representative of IMO, I'm from the German contracting party, and I take the opportunity to give you a short overview of a project we have done in Germany on paraffin residues which were washed on beaches. So just to give you some short insight to this. As also for HELCOM, there was a very broad introduction from where it came from. I also wanted to give you this for MARPOL. It's an international convention for the prevention of pollution from ships. And it was adopted around the same time as HELCOM was founded, but it took quite some time for really getting into force. So I think the protocol from 78 finally was when it officially started, and it entered into force 83. So for the first two annexes, I will talk about the different annexes on the next slide. It is important to see that the general aim of this convention is to prevent the pollution of the marine environment but from the discharges of harmful substances or effluences. And there's a definition of harmful substance in the convention, and this means either create hazards to human health, harm living resources and marine life, or damage amenities or interfere with the other legitimate users of the sea. So this means like fishing or tourism and things like this. So it's a very broad term of hazardous or harmful substance. So just keeping this in mind, because some of these criteria reflect this broad definition of harmful substance. We have 6 different annexes to the MARPOL Convention. The first, Annex 1, is for mineral oil, and this was also the motivation for this convention, because in the late 60s there had been accidents with oil tankers which led to very large spills and really disastrous implications for coasts and the marine environment, and therefore the countries agreed on the basis of the IMO. I did not introduce this yet. The International Maritime Organization is one specialized organization of the United Nations. So I think mainly every country in the world is somehow a member of this organization. And so the main starting point was oil, because this was the most obvious hazard that was there. And soon after this, people considered, well, it's not only oil, there are other things. And so they made the second annex for other liquid substances in bulk. And this is what we will talk about today. So everything which is transported in bulk in tanks, so in large volume and in specialized ships, but which is not oil or oil products. And then later on there were other things like harmful substances in packaged form. So this is the one which is more in line, this annex, with the recommendation for transport of dangerous goods, which is some regulation which is also an international guidance, which is also applied for road transport, train transport, and this is more like dangerous goods classification in containers, in barrels, and smaller unities than in bulk. And then we have the Convention on Sewage, on garbage, on air pollution. The garbage is interesting because on another HELCOM activity, I think we talked about residues from solid bulk cargo ships, and this is the convention or the annex where this topic falls under, because it's a solid waste. It would be considered as garbage in terms of the MARPOL Convention. And the latest is the air pollution, and this is where a lot of activity now is going on the IMO level. And maybe just to say, so there's a MARPOL Convention, and there is this MEPC, the Marine Environmental Protection Committee, on the IMO level, which is dealing with all these aspects. And they meet once or twice a year, I think on average every 8 months for 1 week. And then all these evolution of this regulation of the MARPOL and all associated regulation is discussed and agreed upon. So what liquid bulks are transported? So tankers present approximately 30% of the tonnage of the global fleet for maritime transport. And in tankers, people think that in first place from oil tankers. So this is a very big tankers which are very large capacity, and they typically only have like 4 to 8 tanks to carry crude oil or other oil products. And this is all what would be MARPOL Annex 1 cargoes. And then we have chemical tankers, which are somehow smaller. There are about 5,000 tankers of this type on the global fleet, and they have capacities up to 50,000 cubic meters. But the main difference, or one very important difference, is they have a lot of different tanks because they are used to carry a lot of different cargoes. So tanks are maybe from 1,000 to 3,000 cubic meters as a typical size. And when you look on this ship, it looks more like a chemical factory with a lot of tubes, with a lot of piping openings to really empty tanks separately and to be prepared for a lot of different type of cargoes to be carried. So what is transported? Well, we have the raw mineral oils and products, petrol and diesel. This would be MARPOL Annex 2 cargoes, and everything else which is transported in liquid form and bulk, from paraffins, which has an origin from mineral oil, but it is chemically transformed and is considered as a MARPOL Annex 2 cargoes. But we have also edible oils and fats. We have a lot of basic chemicals or semi-finished product like acid bases like ammoniac, but also, for example, glyphosate, which is a herbicide which has been discussed a lot in recent years, is used in such an amount that it is also transported in tank ships. So this is, I think, the only herbicide which is really used in or transported in tanks, because it's in such an amount. But you also can transport like orange juice concentrates in these tanks. So it's a very vast. Yeah.
So those new biodiesel products which you
Could you please speak into the
mic? Yeah, so I'm just the industry representative. I'm interested in listening. But diesel. So where is the new diesel from? For example, from fatty acids. So is it still MARPOL Annex 1 because it's from vegetable oils? Yeah. So
it's a very good question, and there has been a lot of discussion ongoing, and now there are some possibilities to mix and also to transport biofuels in the MARPOL Annex 1 infrastructure. So you can mix it. So we defined some of the biodiesels when they are transported in mixtures with the classical diesel. But I think if I tell something wrong, Jyrki, you correct me. So there is a possibility to shift between these annexes for some of the biofuels. Maybe Jyrki, just go.
Yeah. Thanks, Matthias. It's great. So we have a new term in that: energy-rich fuels. So these can be transported as MARPOL Annex 1 products because they are chemically similar than, let's say, fossil diesel or fossil aviation fuel, SAF, sustainable aviation fuel, and also gasoline naphtha products. So there's a hydrocarbon system. They can be produced from any material, bio-based material, or let's say, currently we use the term that you can mix, let's say, fossil material and so they call energy-rich fuels. And then we have, let's say, traditional biodiesel, that FAME, fatty acid methyl esters, that can be transported up to 25% per volume, and another part is fossil diesel, and they can be transported by according to MARPOL Annex 1.
Is this new term already in MARPOL, this energy?
Yeah, it's not in MARPOL. It's you know that in IMO we like these guidelines. So it's not it, but it's guidelines. So there is two categories of biofuels. There are, let's say, ethanol, fatty acid methyl esters, and even these vegetable oils, straight vegetable oils, can be that up to 25% can be transported according to MARPOL Annex 1, and then it's these energy-rich fuels that are chemically exactly same than little bit, let's say, not so pure, let's say pure fossil diesel company. I hope that this.
Thank you for this clarification, because Jyrki is much more involved in this question and distinction between the different cargos. So there's IMO, but there's also another organization which is called GESAMP. It's a joint group of experts on the scientific aspects of marine environmental protection, and it is an advisory body for 10 United Nations organizations. So in total we have these 10, I picked it from this report, and there's so this IMO is the one of the most important, and they have also the secretariat for the GESAMP. So they are more like organizing this the meetings for this group, and many of the topics are very closely related also to shipping. So that's also logic that they are in charge. There are a lot of different working groups. For example, some are just working for a few years and then the topic is finalized. Others exist for longer. And the working group 1 is the group for evaluation of hazards of harmful substances carried by ships. And it was established in 1972, so it's the longest ongoing working group. It's continuous effort, and there has been many generations of experts involved in this group. Some others, like for example for ballast water, I think it's 38. It's also already going on for like 15 or 20 years or something. But it's shorter, and other groups are just for a few years, and so. But as it's the first working group, it's still ongoing. It means that it's still relevant, and they are in charge to classify the hazards of the liquid bulk cargoes. And as I said, we have three definitions, or three parts of the definition of the harmful substances, so the marine life aspects. So there are criteria related to this marine life, so bioaccumulation and biodegradation, and aquatic toxicity. We have the human health aspects, which is like acute mammalian toxicity. So this is classically in toxicology that you don't test the toxicity to humans, but you do test it to mice or rats or whatever, and then try to extrapolate that it would be also toxic for humans. And like other hazards like irritation, corrosion, and long-term health hazards. And then we have the criteria related to other uses of the sea. And this is, for example, the behavior in seawater and the interference with coastal amenities, so hazards for fishery or beach tourists or whatever. And from this assessment, there will be created a hazard profile, which is then used by IMO bodies for the assignment of carriage requirements for these compounds. And this is, I don't go into detail so much, but we have, as you said, there's the IMO, and there are different bodies below IMO which discuss different aspects. One of it is the Subcommittee on Pollution Prevention and Response, short PPR. And there's a working group on the evaluation of safety and pollution hazards from chemicals, ESPH. So this is like 2 levels below MEPC. There's like a technical working group on these aspects, and they meet once or twice a year. And Jyrki and I are members of this group as part of our national delegations. So there's all the members of IMO have the right to participate. So Germany and Finland and many others are present, and we discuss how to, based on these hazard profiles and also on other aspects of the chemical, how that should be transported. Because the regulation for tanker transport not only considers environmental hazards but also safety hazards for the shippers. So we, because it can be explosive or some other aspects which may not be relevant for the marine environmental protection, but for the safety of shipping. So there's another big convention that's called SOLAS. It's a safety convention, and both both conventions somehow play a role in the regulation of the transport of liquid chemicals. So, but first of all, I go into this the hazard profile, and this is, as I said, used by ESPH, so the working group of IMO, to do this and to update the IBC code, which is the code which is used for the transport of bulk cargoes in liquid form. Because I'm not sure about your backgrounds, I just want a very short course in ecotoxicology, because we have some values which are discussed. So what happens if you want to say something about the toxicity? You look, for example, you take some organisms and then you add a chemical, and then you look, how is this toxic for this organism? So in this case, like the higher the concentration, the more fish will die. So, and then you just look at, well, how is this relation between the concentration and the effect? Like make a concentration response curve, and then because you don't want to have the single value, you look, okay, we have one value, the no observed effect concentration. In this case, nothing happened, so at that concentration we didn't have any dead fish. And then you have the lowest observed effect concentration, so you have one concentration where you already saw some effect, and then you have the concentration which caused 50% effect. So the EC50 in this case, it's the effect concentration which affects 50%, or it can be an LC50 if it's a lethal effect. So then in this case, it's LC50. And this is important just to, because I show you this, because the lower an EC50 value is, the higher the toxicity of this compound. So a low value for an EC50 means it's a very toxic compound, because you can already, with like 0.1 milligram per liter, you can already kill some fish. Whereas for another compound which only has like 100 milligrams per liter, it's a lot less toxic, because you need a lot more of this compound to kill fish or other organisms. So just to give you this, because it's in the first thought sometimes not so intuitive to see a low value being dangerous. So when the GESAM working group looks at the hazards, there are a lot of different criteria. I show here only the environmental hazards, so bioaccumulation, biodegradation, aquatic toxicity, and you look on the different aspects. So it's not very well readable, but you have a compound and then you classify it in the different, according to the different endpoints you analyze into different categories, and then you come up with some kind of profile which looks like this on the different aspects, and then every compound has some kind of typical profile which is again used for the assignment of the transport conditions. And here I show you just one illustration about the behavior of chemicals in the marine environment, because this is also given in this profile. So you have different behavior, and so you have like some compounds which are gases, which is not probably the ones are transported in these tank ships, but you have compounds which evaporate, for example, others which are floating, others, or they can dissolve, or they will sink. And then you have, of course, different combinations of these criteria, and this will determine how a compound, once it is released to the marine environment, will behave in the environment. And this is something which is also given in the GESAM profile to give users an indication what would the substance actually do when it's released. So, and then there's this famous categorization of this NLS cargoes into the different categories. So we have the category X, it's major hazard. We have a normally hazard and then minor hazard and other substances. So what means major hazard? So that means it's a very highly toxic substance. So the EC50 is below 0.1 milligrams per liter. This means, this is a major hazard. But it could also be only highly toxic or having a long-term human health hazard combined with bioaccumulation and or persistence. So there you can see also the aspect for the human health, because if it's a CMR, means cancerogenic, mutagenic, reprotoxic, so some compounds which can affect human health. And when they are combined with the bioaccumulation, they may be found in fish or seafood or something like this. And so there is this aspect to protect human health by combining these two aspects. Then we have this category Z, minor hazards. These are substances which are basically non-toxic, so toxicity is, the EC50 is more than 100 milligrams per liter, and other substances are like orange juice or something are also non-toxic. And then you have the category Y, this means everything in between. And this is a category we will be talking about today, because it's for what the tank cleaning is under discussion. And this means it can be something which between very highly toxic and practically non-toxic. So there is a very wide range of toxicities which we can expect in this group. So why are the tanks clean? Why is this required? So there are more than 1,000 products which can be transported in chemical tankers, and often you have cargo changes in between. From you unload one and you use the tank for something else, and of course you don't want a contamination of your next cargo from the previous cargo. So, and of course you need also clean it when you have to enter into the tank for maintenance or repair. And as port time is expensive, so the longer you stay in port, in time you have to pay money and you don't earn anything at that time. So there's an economic interest to limit the port time. And so there's an economic interest of the shipping companies to quickly part after unloading and then do the cleaning once they are on the sea. So this is why we have some of the discharges into the sea. So the discharge provisions, according to MARPOL, are anyway, it's always that MARPOL says it's prohibited to discharge unless, so you give more like, the basic is it's not allowed, but it is allowed when the tank is already empty, and for the Cat X, a pre-wash is performed and the disposal of the washing water is done into a port reception facility. And also it needs to be discharged for under certain criteria. So the ship has to have a minimum speed of 7 knots. The discharge has to be done below the waterline. It has to be at minimum 12 nautical miles from the nearest land, and the water where it is discharged has to be 25 meters deep. So the tank has to be emptied. But what does it mean, an empty tank? So this means that the tank and the associated piping, because we have seen there's a lot of pipes, and of course it's not only the tank but also in the pipe where you can have some residues of the chemical. It is 100 liters for older ships which were constructed before 2007 and 75 liters for ships which have been constructed since then, for a whole tank including the piping. So compared to 1,000 cubic meters, it's not a lot. So, but wait, doesn't. Maybe I turned it off. I don't know. This is. Okay. Okay, so these are the volumes basically of Cat Y products which can be discharged without a pre-wash. So if this is the volumes we are talking about after tank is emptied. So this can still be washed to the sea. But I would like to draw the attention that this tests for compliance with these residue volumes are only done with water. So this is when you get your certificate that your tank is compliant, you use some kind of water and see the tank is completely emptied, and then you look how much is still there. And this test is done with water. So in case these cargoes have a higher viscosity, which is maybe more sticky to the tank walls, you may have also higher residues. So it's just, I'm not an expert in this nautical techniques, but this is something which I heard from people who say this is, maybe it's not only this volumes which are discharged in the end. And then we don't only have the residues in the tank, but also there are substances which are used for cleaning. So we have cleaning agents and cleaning additives. They are both mentioned in MARPOL, and I just give you the terms here just to give you the idea. So cleaning agents means washing media other than water. So you can use like some kind of mineral oil or solvent or something to dissolve the residues, but in this case you have to follow the same discharge provisions as for the cargoes in MARPOL Annex 1 or 2. So if you use a mineral oil, you would fall, this cleaning agent is considered as a cargo under MARPOL Annex 1, and so you have to discharge it to a port reception facility. But there are also cleaning additives, and these are products which are added to the water, like a detergent, to facilitate the tank washing. And there are certain criteria what has to be fulfilled that something is considered a cleaning additive. So they need a GSAM hazard profile. So you are only allowed to use compounds which have a hazard profile. And so in mixtures, there can be CADEX products present in cleaning additives. And all these tank cleaning additives need to be evaluated by the ESPH working group. So this is the IMO working group, which we have discussed, which is regulating the transport carriage requirements for liquid bulk cargoes. And for these, there are no additional restrictions. And this means that, so you may ask about the CADEX product at 10%. This is a pretty historic thing because before, I don't know when this was discussed, but like 20 years ago, there was no restrictions at all for cleaning additives. And then they included something to limit what could be there. And this was when this was introduced. And it is still discussed whether we could eliminate this or not. But right now, it is still allowed to have like 10% of CADX products in the cleaning additive. And there's another problem with these products is that as there's no restriction for this, companies try to slip as many products on the list of evaluated products, because then they can be used, and that's more like a white check, or how you say, you can use it. And they try to slip also cleaning additives for other purposes on the list, for example, for cargo holds, for cement or something. In the recent years, we have been very strict on only putting substances on the list which fulfill the requirement that they are. So yeah, I already got some extra time, but I used it up, so I speed up a little bit. Sorry. And so we have this substances on the list which shouldn't be there sometimes. So we are looking for this. So these are the criteria I have already said, and we have products which are not, we shouldn't be on the list, and therefore we have an updated guidance which is trying to be more specific on what can be accepted, and then we want to remove all the old products to have a clean list of only products which are really fulfilling the criteria. So one substance group which has been discussed a lot is something which is not really toxic, so it's a category Y product, paraffins, but we have found these washing upon the beaches in Germany and other countries, because these are products which are solid at ambient temperature, and they are transported at higher temperatures. So you have to heat the tank to get it in a liquid form. So when you wash the tank and it gets in contact with the 10 degree, 20 degree water in the sea, it will solidify and it will form some kind of these flocks. And therefore, there has been additional pre-wash requirement which is in place from 2021, that you have to do a pre-wash also for these CAD-Y substances, but it's not the same pre-wash as for the CADX. So these are the criteria. I don't go into detail, so there's behavior which I said that it's solidifying when it's in contact with the sea. And in Germany, we have had this a lot, and so there had been a study. I just show you some of the results. It's in German, but just a short overview of this. So it was a pilot study, and in the years, sometimes they collected these residues, and this green is a small amount, yellow big, red is very big, and this is where they found on the Baltic Sea in the recent years. It's not very frequent in the Baltic Sea. It's a lot more frequent on the North Sea coast, so because the project was on both German coasts, so we have a lot more on the German coast. And we have this project where they collect this and they analyze what is actually this. Is this paraffins? Is this other things? And we can see that in this case, it's like 20% of this, what was found in the North Sea coast, is paraffins, but there's a lot of fatty alcohols in there. And this is only the one which has been found after 21. So when the paraffins are not allowed to be cleaned anymore, or discharged into the sea. But we can see that the fatty alcohols, they make a major part, and they are officially allowed to be washed because they have not the special requirement. And so we have also incorporated in Germany now the paraffin monitoring in the beach monitoring. So this is just showing that they try to finally analyze what is found in the beach in a way that is reproducible in different areas. And this is shown one also on the North Sea, what they found. So in a lot of cases, they found very few small parts, and in only very little cases, large parts. So these are the first results, so that we can detect them. High percentage of fatty alcohols. The pollution of the Baltic Sea is a lot lower than from the North Sea, but there was no real decline in the last 10 years, and we have a high variability of pollution patterns, and we don't have yet proof for the effectiveness of the cleaning rules of the persistent floaters. So the current activities of IMO, to come back to the IMO, because this could be one of the way forward. So there is an ongoing activity to update the guidelines for the first washing of the persistent floaters. So because the Netherlands have started initiative, and they saw that this cleaning was not really effective, and they propose a guideline how to make it more effective, to have the pre-wash really, that most of the residues from paraffins are really discharged in the port reception facility and nothing is left. Then we could assign new cargoes as persistent floaters, which then would require a pre-wash. This is something which could be done by submissions to the ESPH working group. So if we find frequently fatty alcohols and we say we don't want them, we could say this should be a pre-wash requirement. This is pretty easy. It could be one member state submitting this and saying we have found this on the beach and that's why we want to pre-wash. This could be something which could be done. And well, there's a revision of the cleaning additives guidance note. So this is something which is more or less finalized, but there will be certainly next rounds when the discussion goes on. And so this could also be some point where activities could be focused. And then I'm at the end, and I used up the extra time, but I hope it was interesting and I'm open for questions.
Thank you very much, Matthias. I think it was really interesting. At least it rang a lot of bells in my head, especially this last thing with the paraffins, because I used to work with oil spill response also,
okay.
And clean up beaches as well. So I spotted that myself a couple of times. Well, and another thing actually that I just realized as well, that we haven't met, but we have used your work as the basis for our work on dry bulk fertilizers handling in the Baltic Sea ports.
Mm-hmm.
So your research from 2016 was
the old
ground for our joint work actually with a number of organizations, including John Nurminen Foundation and Race for the Baltic, but also more importantly to the policy action within HELCOM. Mm. So many thanks for that. But what about questions? Yes, we have.
Thank you very much. Microphone off? Yes? I don't know.
Maybe not, so please use this.
Oh, sorry.
Yeah.
Okay, thank you. Oh, yes. You explained about how to measure the toxicity with the fish. So my question is concerning other sources than that substance. Does that way of measuring toxicity also include if other sources are available in the area, and how the status of the fish actually can...
Yeah, it was just an example.
Yes.
So we look typically at 3 species groups. So we have like fish, so as a vertebrate species. We have crustaceans as invertebrates, and algae as plants. So we look at all the 3 different species groups, and then we take the lowest value, so the highest toxicity, as a reference to do the classification. So of course this is also only limited to 3 groups, but it's a lot wider than just looking on fish. So it's
okay, so when it's being translated over to the IBC code, you can expect that there are also other things involved in that, what you take in consideration with creating the IBC code, or is that something that should be taken in consideration by policymakers later? That there are also pressures from acidification and other things?
So, no, the criteria here are only based on the toxicity.
Yeah.
So it's other things like eutrophication is not really addressed in this case. But I think probably it's not that as relevant as the toxicity, because this is rather compared to the nutrients which are released from rivers, from agriculture. The residues is probably not so high, but well, it's
yeah. But the accumulation of other sources are not involved, so it should be taken in consideration by someone else.
Yeah.
Thank you.
Yeah, I have a question about persistent floaters. How did you decide? I don't know if it was you or which substances not should be consist as a persistent floater. For example, tall oil.
So there was this first round where at IMO. This was before I was participating, and maybe Jyrki remembers, but there was some list of compounds where he used it, and then now it's like a iterative process. So like if new substances come up, they can be included on the list. So yeah, maybe you can.
Yeah, thanks Matthias for your presentation. Very good. So in fact, it was decided that these are only vegetable oils, vegetable oil, and I think there are currently 45. So, for example, tall oil products doesn't belong to this group. That we should discuss it later. And there is that famous special requirement 16.2.7 that requires that these vegetable oils, I think it's, as I repeated, 25 currently vegetable oils, pure or technical pure products.
Yeah, so this was not systematically analyzed. At that time, nobody went systematically to all the products in the IBC code to say this is persistent floating or not. So they just said, okay, we have this group of vegetable oils, and the rest has to come by the initiatives of member states. And this is something which I think we could look forward in this project to say what are the other substances which we could propose as persistent floater to be included.
I have one technical question, if you that because in Finland we have discussed how do you define paraffins and these fatty alcohols? Perhaps we can discuss later that, but that is one that what do you mean when you talk about paraffins or fatty alcohols? Which kind of substances? Thanks.
For me, paraffins are just alkanes, so without functional groups. And
any hydrocarbons.
Yeah.
Okay. Thank you, Matthias, for a very interesting presentation. I think I have two questions. The first one, I think I missed that, but when you were discussing the Gesamt Working Group 1, did that group give input to the ESPH group or to PPR directly? Perhaps you can clarify this. And my second question, I think that also relates to Eva Lotto's question. How does, when you do the toxicity assessment, well, you know, seabirds are, of course, one of the groups of organisms that is really affected by this type of activity. How do you factor in that? And if you don't, how can we change that? Thank you.
A very good question. So first, there's ESPH and the Gesamt Working Group are separate bodies, but they can ask for advice. And so, and I'm one person, I think there was somebody else who was member of the two groups. So sometimes it's the same, but most of the time it's completely separated. So ESPH can ask for advice and GESAM can respond, and other way around, GESAM can propose something. For example, I think this activity about the persistent floater was proposed in some part by the GESAM working group. And so it can somehow interchange. The other question is that, like, when it comes to toxicity, the sea mammals are probably similarly sensitive than humans. So in the end, somehow that we have mammalian toxicity as a criteria, which is intended to protect humans, would also tell us something about the other sea mammals, or about sea mammals. But of course, it depends what criteria actually used for the classification of Cat Y, Cat X. So it's only the long-term health hazards which would classify something as Cat Y, Cat X, and not the extreme mammalian toxicity alone.
Okay. Okay, yes, I hope. Yeah, now this is working as well. Are there any further comments or questions either from offline or online audience? Otherwise, if not, I would suggest that we break now for coffee. And of course, you can also approach Matthias during coffee, and not only Matthias, but also Markus. And thank you very much, both of you, for this really inspiring and insightful information. We will reconvene quarter to, what time is it? 2:45, local time, I guess? Quarter to two, sorry. Yeah, messed up the watch. And coffee is served. Okay, I think we should continue. And colleagues, please take your seats. And then now we have two more presentations, and still, as I said in the beginning, setting the scene to a large extent. So we will now ask Anna Lunde Hermansson from Chalmers University of Technology. Well, I'm happy my son is studying there. To talk about tank cleaning and its impact on the marine environment. So Anna is with us online. So
Yes.
Anna, you have the floor.
Thank you so much. I was also told that someone will shift slides for me, so I would be very grateful. And I also want to add that I'm not seeing any one of you, so if you want to ask questions, please raise your hands. Not raise your hands, but shout out rather. And also if you could turn off the microphones in the room, because I hear myself, that would be great. So thank you so much, everyone, for having me. And I'm very sorry that I am not there with you. I had a bit too many obligations to be able to go to Riga. But I'm very happy to contribute with the little knowledge that I have. So my name is Anna, and I'm a PhD student at Chalmers University of Gothenburg, and I will talk to you about tank cleaning and its impact on the marine environment. So the main focus of my research as a PhD is really the marine environmental effects from scrubbers, which some of you might have heard of. But I have been part of doing a pre-study on tank cleaning effluents, and also been working on that a bit in parallel over the years. So happy to be here. Please, next slide. Thank you, worked perfectly. So this is just a snapshot of the ships operating within the Baltic Sea area. And as you all know, the Baltic Sea is a semi-enclosed area with a large catchment area, So we have over 82 million people living around. And this creates a brackish environment with unique and sensitive marine species. So this resilience that we often talk about in a marine environment has already met some struggles just by the location and the situation the Baltic Sea is in. At any given moment, we have more than 2,000 ships operating in the Baltic Sea, and the red ones here, the red dots on the marine traffic, are the tankers. And this is oil tankers, so the Annex 1 ships, and chemical and product tankers, so Annex 2 ships. Next, please. Yes, so with this, I just wanted to show you that this is just exemplifying the 2020 ship passages, and we have several thousands of ship passages each year. And of course, these passages will come with environmental effects. Next, please. Yes, so we have touched upon this, especially with the questions from the audience as well. We have all of these ships have different activities or operational activities connected to the daily operation. And all of these will result in pressures. You can press next. And that could be biofouling, anti-fouling paints release, ballast water release, black water and gray water release, tank cleaning, which we're talking about today, cooling water release that often contains copper and zinc or other biocides. We have scrubber water, bilge water, and so on. So we have all of these pressures coming from ships that when we want to achieve the bigger goal of a resilient and healthy Baltic Sea, we need to take these into consideration. You can press 5 times, I think. Yeah, so these pressures are nutrient inputs, so eutrophication that the Baltic Sea is heavily affected by. We also have input of contaminants, acidification if we add strong acids from scrubber water or also from tank cleaning, but that can also be related to increased carbon dioxide in the atmosphere that is taken up by the sea. We have moving of invasive species and also turbulent mixing that creates these pressures. Next, please. Yeah, so within HELCOM, many of you have seen this, there is this Baltic Sea Pressure Index, which is really nice. So there 17 pressures are listed, and there is a wish to assess cumulative impact from anthropogenic pressures and human activities together. And I think this is very good. However, sometimes it feels like shipping is missing from this equation. We usually think about ship impact as ship strikes or oil spills. So sometimes that could lead to an underestimation. I also want you to look here in the top pressures of these pressure index. We see that hazardous substances and eutrophication are on the top list, and tank cleaning effluents covers both of these pressures. Next, please. Yes, so from a marine environmental management perspective, we need to take into account all of the shipping related activities and pressures, and that involves all onboard systems and all ships operating in an area. And we at Chalmers are working on this from several angles, and I know many others are as well, but it is a tedious and troublesome road to get the full picture. Next, please. So here we have the environmental status in the Baltic Sea from the latest HOLAS assessment. And as you can see, most of the areas are red. So both for eutrophication and contamination that I talked about before is covered by tank cleaning effluents. We see that good environmental status is not in sight. That will be confirmed if you click one more time. And then next, please. Thank you. So we have these goals and ecological objectives of the Baltic Sea Action Plan that has already been presented to you. We have this very nice goal of Baltic Sea unaffected by hazardous substances and litter, where we want to see concentrations of hazardous substances close to natural levels. And then we also want to have environmentally sustainable sea-based activities where shipping comes in. As this has already been presented very nicely, I will not dwell more on this, so we can go to next and talk about tank cleaning, which is really why you are here. So next, please. Matthias has already gone through some of this, but here you see a picture of the Baltic Sea and tanker shipping activity from 2018, I think. So the red, the yellow, the more red, the higher activity or intensity, I would say. Next, please. So what has already been told is that a ship can discharge tank cleaning wash water when it's en route at a speed of more than 7 knots, 12 nautical miles from land, and at 25 meters depth. And if you click next, it will showcase where you as a ship would be allowed to discharge waste, this tank cleaning effluents, as long as you have these en route and more than 7 knots. And as you can see, this is quite large areas around the Baltic Sea. Next, please. So with the background on this, 2019 and 2020, we did this pre-study with the Swedish Agency for Marine and Water Management and the Swedish Transport Agency. And this is also published, and we have had great help from the Swedish Institute for the Marine Environment. I have the link here, and I can also share it with you. And I think there are people in the audience that can help you find this as well, if you find it interesting. But so what we wanted to know with this report is what is being transported, what is being discharged, and also where is it being discharged. Next, please. So the initial question, what is being transported, that could perhaps sound like an easy task, but it was not. So this was took up most of the work actually with the tedious data collection. So I will just go through some of the sources, and it can be nice to have that in mind when we are talking about like future measures on how to understand the impact of tank cleaning effluents. So if you click one more time, we have the Swedish Maritime Administration and also the Swedish Customs that could provide us with specific details for shipping, but we could not separate between IBC, so that is liquid bulk, or IMDG, so packaged goods, which make it, I mean, the IMDG products will not be cleaned out. So there we had a difficulty in that discrepancy. And you can click again. We contacted the Swedish ports and industries and also other Baltic Sea countries. And here we find very relevant data, but it's a very inefficient data collection. And of course, if ports do not want to answer, we cannot force them. So that creates a bias in the data collection as well. Click next, please. We also can make use of European Maritime Safety Agency, Eurostat, so this is more like statistics. And this gave us an overview of the traffic flow and liquid bulk, but we did not get any detailed information. Next. Yes, so we have more national statistical agency and also the Swedish Chemical Agency. Here we get really detailed data, but they do not separate on the means of transportation. So this means it can be transported by a ship or a truck or a train. Next. We also have previous studies, not that many on tank cleaning, but this is okay for comparison. But as you all know, the market is very dynamic and evolving, so it has limited use for today. And I would say that this report that we have published, the data collected in that over what is being transported should also be updated. Next. We also had the information from the Swedish Transport Agency, but here we could only get information on approved exemptions of pre-wash. So when a ship wants to have an exemption for the pre-wash, we could get that statistics basically. So next again. So what we could do with the data from, for example, the European Maritime Safety Agency was to look at the traffic flows. So approximately where can we find the ships that are transporting goods? And we did this flow chart of 2019 data. So in Sweden, within Sweden, we have 529 arrivals, and the distribution from where that came is 63% outside the Baltic Sea, 22% from other Baltic Sea nations, and 15% within Sweden. And then also going from Sweden, there were 249 departures registered, where approximately 60% went outside of the Baltic Sea, 9% to other Baltic Sea nations, and 31% domestic. And within the Baltic Sea area, we found a total of 242 ship calls. And every loading and unloading of the cargo could also be associated to an operational tank cleaning and a discharge of tank cleaning effluents. Next, please. So what is being transported? Based on our data from 2018, we saw that there were about 5 million tons transported to and from Sweden, and we managed to identify 65% of them approximately. And the large majority of these compounds are the category Y products. Also within the Baltic Sea, there are more than 12 million tons transported, or were 12 million tons transported, and again, a majority is category Y products. And you can find a full list within the report, but it will take too much time to go into detail of that. So what we thought and what we think is that most ships that transport these goods follow the regulations. So category X products will not be discharged into the marine environment, but it's the category Y that do not require pre-wash, and category Z products that are like the main players here to look into. And we also suspect that what is discharged is also correlated to what is transported. Next, please. So we wanted to do like a back of the envelope assessment of the risk of these discharges. So we used conventional risk assessment methods. And gladly, Matthias has already explained to you a bit how you do ecotoxicological studies to come up with a number or like a safe concentration. So you can compare that safe concentration with a predicted environmental concentration. And we did that. So if you click next, you can click for next, I think, actually. Yeah, perfect. So we calculate a predicted environmental concentration from this simplified equation where we have the concentration of the slop, so the concentration of the products, including wash water that is in a holding tank, you can say. And then we also have parameters that describe how much of these compounds are associated to particles or will be in dissolved form. And then we also need to know the ship speed, or we can decide on a ship speed, and then also an estimation of the ship wake, and that will determine how much the discharge will be diluted after the ship. So we can go to the next, please. So we can do this for all of the substances where we have these safe level effects. This is also called a predicted no effect concentration. And then you do your ecotoxicological tests, and then you add an assessment factor for including the uncertainty in your test. And then you can compare your predicted environmental concentration with your predicted no effect concentration. And if that is above 1, you say you have an unacceptable risk. And if it's below 1, you say you have an acceptable risk. So we did this here in this example for 4 different compounds: methanol, ethylene dichloride, phenol, and sulfuric acid. So all of these are transported as liquid bulk, and they have different use, but mostly used as raw materials in the chemical industry. For ethylene dichloride, it's to make PVC, for example. Phenol to create other chemicals, sulfuric acid, and so on. Yes. So the different bars here show the estimated volume that is left in the tank after you're unloading your tank. So 0.1 liter is when you have a so-called super strip system that can empty the tank a lot. And then you have I did on 10 liters, 75 liters, and 100 liters based on the different regulations from the IMO and the IBC code. And as you can see here, it varies quite a lot how much you have left in the tank. Obviously, if you have more left in the tank, that will imply a higher risk when that is discharged, just because you have a higher quantity that is being discharged. I just want to emphasize that on this example here where we calculate, it's for one ship with a continuous flow, but it's from one ship and only for one compound at a time. And the previous speakers touched upon this, but if we want to make a full assessment of tank cleaning effluents, we should also look into the combined effect. So sometimes a ship can discharge many different chemicals at the same time. Next, please. So what are some of the effects that these substances can have in the marine environment? Next, please. So it's not only mineral oils that can create damaged feather integrity, also what we call non-hazardous oils or vegetable oils. They will also damage the feather integrity of birds. Next, please. We also see starvation or intoxication by ingestion. Matthias showed these wax lumps that goes up on shore. If these are absorbing different, very nice that you press next. So if these are absorbing different other toxic compounds, maybe the original wax is not toxic, but you can create a toxic mixture within the wax that is eaten and then lead to intoxication. Next, please. Hello. Yes, thank you. So we also have these said compounds that is also nutrients, and if you add them to the Baltic Sea, that is also already prone to eutrophication. That could lead to increased eutrophication. We have acute toxicity effects, often on smaller marine organisms, but that can transfer up in the trophic chain, so affect fish as well. Next, please. We also see chronic toxicity effects, sublethal effects, so that could be like impaired growth or development. Oh yeah, sorry, I don't have the full screen here, so I missed the last one as well. The wax lump can also end up at the bottom of and then lead to anoxic benthic systems, and we also have a problem already with that in the Baltic Sea. Not related necessarily to suffocation by wax, but we don't want to add to that problem. And then finally, as I said, also we have these synergistic adverse effects. That could be a combination of all of these. It could be a combination of many chemicals that have the same mode of action. There could be acids, for example, changing the bioavailability of metals that is being ingested or taken up by the gills on a fish. So yeah, many examples and complex. Next, please. I also thought it was really nice that Matthias showed this, the definition of a hazardous substance, and that it should not interfere with other interests. And this map here shows marine protected areas as the green ones, the ecological and biologically special areas in the blue, and then also fishing intensity in orange, together with the tanker ship intensity. And as you can see, there are many areas of conflicts within the Baltic Sea, and the discharges of tank cleaning effluents is not necessarily only happening just where the ship is, but it will be distributed all over. Next, please. So with this, I want to thank you for listening. And if you have any more questions, I'm happy to take them now, or if you need to think about something, you can always contact me afterwards. So thank you so much.
Well, I don't know if there are any questions in the way. Well, there are for sure.
Thank you, Anna, for this very interesting talk. I was wondering, for your analysis of the PEG-PNIC ratios, what volumes of water did you put into this equation, or for which area would this PEC-PNIC ratio be higher than 1, or for how long will this ratio be above 1? Because after some time probably there will be a dilution, but probably you did also the assessment to see on the Baltic Sea level, if you add like hundreds of these compounds per year and they don't come out and they don't degrade, maybe we accumulate these effects also. What could you say to this point?
Yes, thank you so much for the question. So we did not do, this was kind of a back of an envelope calculation. So we did, you can see it as a cross section after the ship, and then we had a constant speed and then also a constant discharge rate based, I think this ship had 10 tanks, and we assumed that you have, and then we recalculated the concentration after a washing of the tanks according to the IBC guidelines. I don't remember the details now, but they are listed in the in the report. But so what we did was not to look into the accumulation or dispersion after some time. It was more of a snapshot when it's discharged, but calculated on cross section of a quite large ship wake. I don't know if that makes sense, but it was more to see, do we have a potential hazard or risk of these discharges? For your other question on looking into like residence time of hazardous compounds in the Baltic Sea, we did not have time to do that, but of course that is a very interesting thing to do.
Thank you very much for both question and answer. Are there any further questions either in offline or online audience? Yes, Jyrki?
Yeah. Thanks, Anna, very much for your excellent presentation. I have only one comment that we were that the data collection, it requires, we have tomorrow discuss more what we have done in Finland, but it requires, it's not easy one, but I think that we have some hope for that we can collect the data, even existing data that we have. So that's the problem, but it is possible. So I hope so. Thanks.
Yeah, thank you. I think from this perspective, HELCOM and all the HELCOM member states can be really helpful and important players to coordinate this. And of course, it's private interest involved as well. Maybe not everyone wants to share, and maybe also safety reasons for not sharing what you're transporting, of course. But I think it would be very helpful. And now with more biofuels coming into the market and a lot of unknown substances being transported, like the quantities are unknown, I think maybe the HELCOM member states can at least coordinate to get more data, or easily accessible data.
It's a very good point. I think that perhaps Markus is already typing in as a note. And certainly that would need to be addressed then by Maritime if any kind of data collection is arranged through HELCOM, but I am quite sure that it will be done or should be done in a very secure mode. As you say, this is sensitive data from different point of view. And I was myself wondering if there are no further questions. I was myself wondering about the risk assessment methodology. If you could suggest something, well, some hints, some advice. We will discuss it tomorrow, as Jyrki said, also. But maybe some hints for other contracting parties, which mistakes not to do.
So I think there are many mistakes that can be done because it's very complicated, but you don't want to overcomplicate it because then it's going to be very difficult to make any assumptions at all. But I think one thing is to not only look at one substance at a time. do a combined assessment. I mean, there are methodologies. The easiest one is to just summarize the hazard index or the PEC-PNEC ratios, for example. That is, it's not a perfect method, but that would give some estimate of the combined risk. From my perspective, that look into many different like marine environmental impacts from shipping, adding some factor that could account for other pressures would also be nice. How to quantify that factor is, of course, up for discussion, but just to have it included in some sense, I think would be very important. And then, of course, there are some studies where you look into more substances at the same time, so not only one at a time, and then you can get an idea of the synergistic effects of that. But knowing the quantities and how much is being transported and potentially also discharged is a very important first step in order to know what is going to happen in the marine environment.
Thank you for this response. Any further questions? No? Okay, then thank you once again, Anna, for your presentation and your input to the work. And we will then continue with the next input from Swedish Coastguard, from Erik Stålnacke, who will talk about observations about tank washing discharges in the Baltic Sea. Well, I should say that while flying this morning to Riga, I caught myself in kind of a professional deviation since Lon, that I looked out into the water and there was a nice weather, and you always try to spot something. Well, the floor is yours, Erik. So how it is done by Swedish Coastguard.
Thank you. And excuse me. Thank you. Can I pull this one closer? Do you hear me? Yeah. I'm very happy to be here. I'm a Coast Guard officer within the Swedish Coast Guard, as I said, and I'm a surveillance officer. I'm been flying around with the Swedish Coast Guard aircraft since 1999, and I have seen these changes. First, in the beginning of the end of the 90s, we had these mineral oil pollutions, and they kept on in the beginning of 2000 up to 2010, and after 2010, the mineral oil pollutions are almost gone. But at the same time, we also saw this type of other harmful substances. We saw them very early, but not so often during the beginning of the 2000, for example. But they increased, and we know that 2007 the pre-wash word was introduced, and everybody thought that now it will be gone. They will be gone. We will be free of this type of substances. But we know that it's not like that. Even though the newest introduction of the persistent floaters, we hoped, we thought that it will help us a lot, but it didn't help us that much. I got some information from Julia about what do you want me to say when I'm here, and she sent me some topics, and these are the things I will present today. Once in the beginning, how do we in the Swedish Coast Guard approaches these spills, this type of spills? How do we observe them, and what is the protocol? I will talk about that. What happens after the spill is identified. Samples, do we take samples? Observations, okay, by ships or planes. Statistics, I will talk about that too. And in the end, a little bit on thoughts on how this type of happenings can be avoided. And if we start with the Swedish Coast Guard, we have 3 aircrafts of this type, and all our observations of this type of substances, suspected substances, are made by airplane. It's almost impossible to see this type of spills. It's very difficult, at least, from a ship. In Sweden, around our coast, we are flying around approximately 2,100 hours every year. A typical flight path. This is a flight path for November 23 last year, for example, that shows that we are most of the time flying around the south coast, along the busy traffic lanes from Beam, Gothenburg, in Kattegat, around through the Sound, Arkona Basin, Hana Basin, and and passing these former fishing banks. There are no fish anymore at these banks. But anyway, following the lanes up towards the Bay of the Gulf of Finland. We are flying a lot in this area, as you see, and we also find the spills in these areas. Up north, up in the Gulf of the Botnian Bay, we are not flying that frequently, approximately once a week. And that means that we make approximately 70 detections of this type of substances every year. And we find them, of course, along the ship lanes, the busy ship lanes. Why do we do that? Yes, of course, we are flying. Where we fly, we find them. If we don't, areas where we fly not that often, of course, we don't. That doesn't mean that there are not any spills in the Gulf of Bothnia, for example, but we fly there much seldom. That's the reason why it looks like that, and that means that it's some type of hidden statistics. 70 spills. That are what we found, but there are many more, many more, probably. We also see that's the answer of my. That's what I said, and of course we also see some areas with higher, frequently more detected spills, and that's because there are harbors close to these areas that are handling and dealing with these substances. In the south, in the Hana Basin, for example, Gothenburg, outside of Stockholm area. How to find and how to define these substances. It's not that easy. Yeah, it can be easy to find these spills. We have sensors, of course, but how do we define them? And of course, during the years we receive experience and knowledge how they look like. We compare them. As I said, the spills of mineral oils, they are almost gone. But they have a special typical color, which this type of slicks does not have. We do not calculate with natural generated phenomena such as algae belts, ice, other type of, as you saw today, when it's calm. We have areas with calm fields on the sea. But we don't calculate with that one, of course not. The spills we calculate, they are almost invisible. They are just showing up a mirror-like surface, almost invisible from above. You see it from an angle, of course, but when you come close over it, it disappears. You can see some lumps, some type of this paraffin wax lamps you showed up earlier. That's what we can see in different colors, from white to almost black, and all the colors in between white and black. We also receive experience, of course, because if we have an ongoing pollution, ongoing tank cleaning operations from a ship, we talk with the ship. We ask the ship, and he or she the captain or whoever answered the radio call, they explain what they are doing, and of course they know what they are. They always have the right answer. They're doing according to MARPOL Annex 2, of course. But that gives us a lot of experience. We know that we remember how, for example, palm oil looked like, rapeseed oil, or any type of vegetable oil or tall oil, which we learned that it's not a vegetable oil. Yes, that's good. We also plan our patrols along these busy ship lanes through the Baltic Sea, of course. Historical knowledge about where do we find these spills? Yes, of course, we find them where close to the ship lanes, and close most of the time close to the areas and the harbors that handle these type of substances. And we have sensors. During today, for example, it's okay when it's clear, sky clear. You can see it by visually, but SLAR, side-looking airborne radar, for example, and the infrared FLIR, it shows up these substances very clearly. They look exactly the same as a spill from a mineral oil. And what do we do when we detect, when we observe these spills? Documentation of many different kinds, especially from sensors. They can look like this. This is a SLAR images of spill. This spill on the black on this image is a spill detected by radar. In this case, it was around 77 nautical miles long, for example. The ship had performed pre-wash, of course. And photos. Photos were in evidence case. It's important to have a photo where you can see in front of the ship and after the ship. That's in this case it's an tall oil pollution, so it's not illegal, and he did according to MARPOL Annex 2, of course, and he did in this case he performed pre-wash too. Yes, I remember that part. But this is how we do photos. We also take if you see any colors, we do it from above like this, of course. And we do as much documentation with our our camera, our FLIR camera. We look at if they follow the rules according to the underwater outlet. It's quite easy to see too. See, oops, the wrong button. It's coming from underneath the water level. And we have a checklist that we follow, and that is because we want it to be as easy as possible, especially with the contact with the ship. We know we have some issues here that we ask the captain to receive the same information and to make it more equal between our crew members, that everybody should feel safe to make a radio call to the ship. In this checklist, it's also written that we ask for copies of the cargo record book, for example, and that is just it's very convenient to confirm what they say if we see the cargo record book, and they send it every time. That's not a problem. They are very cooperative in that way. Sampling. Do we take samplings? Yes, we have on board an oil sampling buoy that can store this type of substances too. They and it happens nowadays that we drop a buoy within the slick, but most of the time that happens when we have some illegal, for example, within 12 nautical miles from land, or some other reason that's not concern when these tank cleaning operations not follow the MARPOL Annex 2 regulations. we don't drop them just by that, just like that. But and that's you also, Julia, you asked a question about costs. What does it cost for a Swedish Coast Guard? Of course, it costs a lot to fly an airplane. It's not cheap, and it's buoys. They are not cheap either. But we do have buoys, small sampling buoys, but we don't use them that very often because we don't see the reason, because if they following the rules and if they have this pre-work certificate and everything, it doesn't matter if it. We believe them. It is an MARPOL Annex 2 substance, and okay, that's not. It doesn't matter if it's rapeseed oil or palm oil or any other type of oil. The information that we sent that we receive during our document when we collect the information, we send it immediately to the command center. Everything, including videos and everything, we can send it online. And as we said before, the cargo record book, it will be sent to the command center. We give the email address to the command center. So if we have a ship, contact with the ship, we do it like that. We send the information also, even if we don't have a red-handed ongoing polluter. That's just because to receive statistic about how many slicks do we find every year. Our preliminary investigation manager decide how to proceed, and most of the time it's almost most interesting is where did the pollution, where is it detected? Is it detected within 12 nautical miles within the territorial sea? It's very interesting, of course. It's easy, then it's a crime. It's not legal to do tank cleaning within 12 nautical miles. Most of the slicks, they are detected on the economical zone, and it's quite difficult to find any ship on the economical zone. You need a lot of. It's almost impossible, I would say so. And we have the next criteria, Natura 2000 areas, as Anna talked about earlier. That's also something that we check. We have that areas within our map system on board, and we see if the pollution is ongoing. And that's the next. That's also a problem. It's a global problem, I believe. The ships in the MARPOL Annex, it's not in any annex in MARPOL. They are not talking about Natura 2000 areas, and there will be a fight between in Sweden, in my case, Sweden with our Natura 2000 areas and marine protected areas, and a ship from anywhere who doesn't know about this area at all. And it's not written that it's forbidden in Natura 2000 area either. But in the after work or whatever, for the preliminary investigation manager, it's very difficult to keep on and for further investigation. And we know that because pre-work certificate of different kinds, endorsement in cargo record book it's written that he did the pre-wash. We can't do anything about it. Here's an example from a cargo record book. Everything, and you can read by yourself. Yes, of course. Yes, of course. And they are empty. Tanks are empty. Absolutely. Name, stamp, label, company. This is a Swedish company. It doesn't matter if it's a Swedish. It's the same. It looks the same if it comes from Germany, from any other country, Finland. It looks the same. And I understand that. In this case, this specific cargo record book copy, it shows like this when these ships leave 12 nautical miles. Sorry, I can't point straight. But here, when he starts here, that's 12 nautical miles out from the Swedish baseline. And he starts tank cleaning, and then ongoing, and then at this moment, the slick is 25 nautical miles long. Visually, it looks like this. Underwater outlet, absolutely, no worries. This is tall oil. Then it's not a compulsory pre-wash requirement for tall oil, but in this case, they made pre-wash anyway, but it looks like that. This is another happening. This is palm oil. Also pre-wash. And the worst of all, that this is a bad image, because in this case it's not a tank cleaning operation, it's a deck cleaning operation. And this happening, it is an accident, of course. It shouldn't look like that. But they were cleaning deck from this is palm oil, crude palm oil, and they tried to get rid of it by hot water, and we stopped them, of course. But now at this moment, it's calculated as Annex 5 crime, cleaning cargo residues from deck. But this ship had also a pre-wash certificate. And in the pre-wash Appendix 6, you can read that it's the piping and the tanks should be empty. So in this case, it was not empty. For example. And that is how should we change? What should we do to get rid of this? I'm just a Coast Guard officer, a surveillance officer. We find this and we try to go as deep as possible to be able to find them. Because it feels like if you get fined somehow, you maybe stop doing it. But they keep on. And we had, as I said in the beginning, we had very good. We hoped a lot about the pre-wash, the word pre-wash, 2007, and we were very happy with the pre-wash requirement, the persistent floaters, 2021, but nothing happened. It looks the same, exactly the same, and I hope that it is really unloading, cargo handling. Issue, and the pre-wash or MARPOL surveyors or whatever they call, they must be more educated. They must, I don't know, but we can't do anything out on the sea as long as it looks like that. And MARPOL Annex 2, it gives them free hands by this cargo record book. Stamps, endorsement. That's the only thing he need. The ship. He doesn't need any other certificate. Nothing. And that's it feels very strange for us who see these slicks. I didn't say that, but this year until today we have 27 slicks, 27 detections. One. Today I have some images in my computer. There was probably palm oil, for example. So it's happened almost not every day. 70 slicks. It is not every day because there are 365 days a year, but it's more than once a week. And if you don't have any questions to me, and I will be here. I'm very happy to be here and listen to you, and I'm looking forward to the rest of the session and especially to the discussions.
Yeah, thank you for the pictures. Representative from the terminal, exactly with those materials. So very sad to see the pictures. My question is about the surveyors. So what is the situation in Sweden? Then who is the surveyor who approves the pre-wash procedure in your country? Is this point somehow affectable? You can affect them to be stronger, or maybe to respond about their actions? This is the first question. And the second one is, maybe will the presentations will be available, because I will present those to our terminal managers to see what the others can see from the sky to learn.
I will leave the answer for one of your questions to the Swedish Transport Agency. Is that okay?
Yes, it's okay.
Yeah, but because I agree totally with you, and it's not my responsibility. And I'm surprised because when you talk with the other cargo owners, for example, the Swedish Preem or whatever, they are very surprised. They don't want it to look like that, because they need all these substances. They need every drop of this substance, and that's strange for me, who can see this every day, that it is like that. And I'm surprised that he was surprised, and I am even more surprised. But Carolina, please.
Thank you. About the inspectors in Sweden, we finally get a new education for them last year. So in September last year, we had the first education for MARPOL inspectors in many years. And I have started a network like Finland with the MARPOL inspectors, so they will be updated and stronger in their role as an inspector. So they feel they have the Swedish Transport Agency behind them, not as something that they have to answer to. Is it the answer to your question?
So it is the Swedish Transport Agency that provides surveyors and inspectors to certify.
Yes, it's an independent company, but we have a group of inspectors and we have meetings regularly now. It's a big difference since I started 2022. And thanks to Jyrki that gave me the idea.
And we will also discuss the issue about the inspectors tomorrow, so in more detail, which Jyrki will tell about.
Yes, thanks a lot for this talk and the pictures. And when we look at the quantities, it's difficult to estimate, but the 75 liters for me, I think would look very different. You could not see this for this, and so I think we have really a problem on the efficiency of the pre-wash. You said you were happy for the pre-wash requirements in 2007. This was for the CAT-X cargos, or because we don't have a real pre-wash requirement for the CAT-Y products.
2007.
For the CAT-Y. The CAT-X, yes. Because the majority, as Anna presented, are CAT-Y, and there wasn't a pre-wash requirement, and for most of them there is not. And there's no efficiency criteria for the pre-wash either. So this is a problem which is now a little bit tackled in IMO by this proposal from the Netherlands to have a guideline how this pre-wash has to be done, like with a temperature, water temperature, which is, 10 or 20 degrees higher than the melting point of the cargo or something. Because otherwise you can just put some water, say we did the pre-wash, you get the certificate, and the efficiency is not a point. And I think if we can move on to have more criteria for the efficiency of this and include more substances, because I think for the palm oil there's no pre-wash.
Yes,
for some of them. For some of them, yes, but for the most of the vegetable oil, yes, but there are more other compounds which could be requiring this because they have the same behavior in the environment. So we can move on with this.
That's interesting, but that's true. It was not a pre-wash requirement connected to any specific substance, but it was connected to the unloading temperature and the melting point of the substance. and that's the next problem. IMO, when they find melting, solidifying or not solidifying substances, I don't understand why they have to mix up temperatures in that case. If you heat up solidifying substance, then it's not solidifying, and that's correct because it's easier to handle, but it's still solidifying. But not in MARPOL Annex 2. If you heat it up a little bit more, 10, 15 degrees, then it's suddenly not solidifying.
Yeah, thank you very much. And yes, Fredrik?
Yeah, thanks, Erik, for this presentation. I was just thinking, when you showed us the image of detected spills within the Swedish economic zone, but sometimes you fly very close to Finnish economic zone, for example. If you detect a spill in other countries' economical zone, do you contact your representative in other countries to with this information?
Yes, absolutely. On this slide, it was only on Swedish economic. But if we find it in Danish, German, Finnish zone, we transmit all the information, the same information, directly to them.
Okay, thank you.
Markus?
Thank you very much, and I think we are running out of time for this one, but hopefully we can discuss a bit more. Very good presentation, thank you very much. And I just wanted to, first of all, point out that HELCOM is also publishing these annual reports of spills detected by aerial surveillance in the Baltic Sea. And we are actually currently working on the 2023 report. It will be submitted to the Response Working Group for approval. So published hopefully before the summer break this year, if it's approved, or no, actually it might be until August or September. But anyway, it's coming, and all the previous ones are on the HELCOM website. So there you can see more a bit about what kind of detections have been made. But when it comes to spills like this, most of them are like unknown. And without, so for our purposes here, it's probably not going to provide you with that much new data that can be used, but still it could be interesting to have a look at all these detections over the years as well and see how it's changed. But I have a question as well. I guess you are able to somehow also like quantify the spills, like based on the surface area it covers and what type of product you think it is, to calculate how much of that product is there. Is that something that you do? And also, can that be used then for convicting those who claim that they have done a pre-wash but have provenly not done so? If you can see that this is 1,000 cubic meters and not 75 liters.
The short answer is no. Yeah, that's true, because they are with the mineral oils. There have been a lot of research through many years. From in the beginning of the 90s, they started to learn how to calculate mineral oils, and that's because it's depending on colors, different colors. In this case, there are no colors, so nobody can calculate. But there is probably some type of research work starting quite soon, maybe, because I heard that yesterday that there are some. I think it's a Norwegian company that has possibilities to do this research, but it's not for free. Somebody has to pay. Maybe HELCOM can pay, because that's a problem.
Yeah. And as I mentioned earlier, HELCOM is the HELCOM contracting party. So then the countries will have to pay. Yeah, they pay our budget anyway, and it's limited.
Yeah, and that's a problem because in Sweden, it's very important for our prosecutors to have some type of amount I don't know why, but that's how it is. And that's also one problem when we find some illegal thing. They need an amount of, and we don't have that. It's not, nobody has that. And a short answer to your question about 75 liters, and that's after the unloading procedure. After that, you make a pre-wash, and that's even less. Then this 75 liters should be nothing. And that's not true. That's okay if you do it, if you check it with water, then it's okay, but not with carbon.
Just one very short comment, because the only thing we can see is floating, solidifying products. Everything which is dissolved or sinking cannot be seen anyway. So I just want to highlight this is also impacting the environment, but not visible.
But the system, the substances that are not floating, they are more easy anyway to get rid of from the tank. It's not that sticky as a floating, persistent floater. I agree totally with you.
Yes.
One comment.
Go ahead.
Yeah. Thanks so much, Erik, for the excellent presentation, illustrative work. I only say that there are some category Y products that has mandatory pre-wash. And in Finland, we have the system for MARPOL inspectors that also category Y products shall be inspected. And I think this approach is very good for all the Baltic countries, because Matthias knows that there was a few years ago for MEPC that the Netherlands this proposal for new work item for that we start to discuss with ESP's technical group in this, and it seems that they even start the discussion that perhaps tomorrow when we have this workshop, we should think that what are the pros and cons to make also these category Y products mandatory pre-wash, because we could do done it by our national legislation. We didn't need any, sorry Markus, for HELCOM or for IMO for that, and that is, I think that it's working quite good. So that's only one comment, so I will continue later. Thanks, Misha.
Jyrki, and we do have time, no worries. And in fact, what you just said about the national regulations versus IMO regulations that can be easily achieved, I think this is exactly what HELCOM can do, because then it wouldn't require, if countries would really are willing to do that, then it could be introduced nationally, like you say, without really waiting for something to happen at IMO level, which we know takes time. And there are examples, of course, of this type of actions already. But I also wanted to thank Erik for really, well, inspiring but also dramatic, I should say, presentation, because when I saw you speaking, I think it was at Maritime meeting already presenting this, and you even gave another example that I actually wanted to ask you talk a little bit about, but maybe not now. I think you showed also one case when a ship was deliberately leaving the port, going out 12 nautical miles, discharging, and then coming back. So that was the procedure. So probably they even claimed pre-wash as well, but they didn't deliberately. It was, I think you referred to that case once.
Because in Germany you don't allow that. I can go to this one. In Germany, you do not allow that happening. But in Sweden, we don't have this in our legislation. It's written that you just have to be under minimum 7 knots. It's not written en route. It's not considered in the Swedish legislation. That's the reason. So that's the reason why it's okay in Sweden, but not in Finland. I don't know, but in Germany, I know it's not allowed.
Good, and a couple of other points that I make a note of, and one was about MPA. That thank you for bringing it up. I don't know whether it can be in any way considered in IMO or HELCOM discussions, whether well, a discharge, a legal discharge can be allowed within the MPA area. And as you could see, Matthias, we have plenty of MPAs in the Baltic Sea. Still a few more, hopefully, to be added, but nevertheless, I do understand it will be difficult also to, well, global traffic to be updated about the MPAs and whether a ship is allowed or not to discharge in a very specific area, but something can be done. And I think the second point that I also noted, what you, Erik, said about how the situation developed with the mineral oils and mineral oil slicks gradually disappearing from the surveillance, which is, I think, a very great achievement. I don't know whether it is the same trend global or whether it is only Baltic and maybe OSPAR. But this is, I think, partly because of the efforts that were done within HELCOM and the reception facilities strategy being introduced quite long ago. But that addressed only ship-generated discharges, so it addressed bilge water and sludge, I think, only. And of course, yeah, some accidental discharges perhaps. But maybe we should think about something conceptual in the same way, so that we have Baltic strategy for cargo-generated waste as well. So that reception facilities are more easily available for this type of cargo. And as far as I remember also from the Baltic strategy for reception facilities, cargo-generated waste should not be allowed to be discharged free of charge, but at the cost of cargo owner. But that perhaps introducing some kind of incentives may work, or may help at least. Okay, but thank you very much for this lively discussion. And we will now move to examples how to decrease discharges in cooperation with industry, and I will pass to Julia first, and I will join her as well in this presentation a little bit later. So Julia from John Nurminen Foundation will talk about chemical tankers project and what we did so far.
Yeah, maybe I can bring some positive light to the situation after all these negative effects. I'm Julia Suikola from John Nurminen Foundation. I have worked there for 2 months, but before that I worked at Traficom, and I was also on this project, so maybe I know something. I'm going to talk to you about how the foundation is trying to tackle the problem of the washing water emissions on voluntary-based actions. And this project is done in cooperation with Coalition Clean Baltic, Finnish Transport Agency, and then the Swedish Transport Agency. And first, just a few words about our foundation. So our main mission is to save the Baltic Sea and its heritage for the future generations. Our projects aim to improve the state of the Baltic Sea by reducing eutrophication, the load of harmful substances, and also by restoring marine nature. And we want that our actions are measurable and effective. Between 2005 and 2024, we have launched dozens of projects. From this map, you can see what we have done and where. Before, we had many projects in the East Coast, like wastewater treatment projects, but now we are focusing more on diffuse load in other areas. Then Misha will tell a few words about CCB.
Say a few words also about us being the partner in this project. And Coalition Clean Baltic is an NGO network of 27 member organizations from 11 countries around the Baltic Sea, both big and small. Well, all of them are listed with logos above. And what we are very happy about is that we have around 1.5 million people behind those organizations, not just individual members, but members of those member organizations. And we operate since 1990, so it's already a little bit outdated slate. We'll celebrate 34 years soon in June. If you can change the slide. We also have a vision of the Baltic we want to achieve with enough pristine and wild nature and coastal areas, acting as safe havens for animals and plants and being removed from harmful human activities. Well, of course, a lot of good words, but how do we achieve that? We are working in different directions. I don't remember if I had another slide. The directions are actually presented here as well. So we work on eutrophication, hazardous substances, biodiversity, nature conservation, as well as hazardous substances and harmful activities. And we are basing and supporting a lot of work to policy advocacy, and that is also reflected here on the slide. But then we have another slide, I think, about the problem. When I heard, Erik, you talking about the flights in Botnian Sea, or Botnian Bay, and the frequency that is like once a week, I actually realized that the last few cases of the big spills of tall oil have happened exactly there. Because quite many of the harbors and terminals that are dealing with the tall oil are located in the north of Sweden. And this is just a snapshot of a study that was carried out by research, but also by the consulting company Sweco, that reflects how difficult it is actually to deal with tall oil, not only in terms of detecting the spill, but also in terms of actually responding to a spill. And I unfortunately had a personal experience myself, on the other side of the Baltic though, not in Sweden, where for the first time when we saw tall oil being splashed ashore, it was actually difficult to say what it is. And exactly then understanding that this is not exactly the same substance as we used to deal with, like heavy fuel oil or just oil, it appeared that, maybe it is not as harmful, but then realizing afterwards, potentially it can have exactly the same effects. And of course you can see, or if you would wish to look later on into the slide or into the documents related to this particular study, it can have the same effects. So it will hamper and make problems for seabirds, for example, or waterfalls. It will really contaminate the coastal reeds, for example, or any other vegetation, and it is difficult to handle in many senses. So this is one of the reasons why we wanted to address this issue and why we are also in cooperation with John Nurminen Foundation.
Yes. The spills and the problem in general has been in the Finnish news media as well in the last years, from general public but also from authorities. And the fact that this is in the Baltic Sea Action Plan, which Markus elaborated greatly, I'm not going to go further into that. This attracted our attention and activated us to start to work to minimize the emissions. But a little bit about the project and the steps we have taken. The main goal is of course to reduce the discharges of the harmful substances from tank washing. And the first step was to make a risk assessment, which Traficom did wonderfully. We identified the chemicals handled in Finnish ports that could have the potentially harmful impacts on the marine environment and the human health. This was based on also the amounts that are unloaded in the Finnish ports. And these are all category Y chemicals that are allowed to be discharged. The identified risk chemicals were crude tall oil, styrene, benzene, and also pyrolysis gasoline, butyl acrylate, and vinyl acetate. And after we had identified these chemicals, the next step was to contact all the chemical industry and the businesses to find solutions together to make this happen, to reduce these emissions. To contact these chemical businesses, the first step was, of course, to identify the chemicals, and after that, identify the ports where these chemicals are being unloaded. We did this by collecting the data of the chemicals unloaded in Finland, and also contacting the ports about the companies. They have been happy to help in Finland, but as we heard from Anna, that might not always be the case. And after we identified the chemicals and the ports, we contacted the companies using those chemicals. And after we found out what the companies are, the next step was to contact all of them. The companies have luckily been quite responsive and have at least agreed to meet us and hear us. We have introduced them to the impacts of the discharges that come from their business and have talked about the producer's responsibility in the chain. And we have also discussed about the fact that the regulation is likely to be tightened in the future. And we have tried to encourage the companies to act as pioneers before this becomes obligatory. And after these introductions, we have had discussions about their current practices and then trying to find solutions to handle the washing waters on shore. To have these discussions, we have had workshops for all the companies using the specific chemical, and the aim has always been to gather the best practices together and then implement them to avoid these discharges. In the case of crude tall oil, last year all the Finnish tall oil refineries agreed to minimize all of their emissions to the Baltic Sea. So we don't have any crude tall oil emissions coming from tank washing from Finland to the Baltic Sea at the moment, hopefully forever. And examples of these best practices in the case of crude tall oil have been loading the chemical on top in the same tanker after it has been unloaded of the crude tall oil. And as well washing the tanks with fresh water or seawater and taking the washing waters on shore to treat them, for example, in a wastewater system. Sadly, the solutions aren't always cost effective, and the solutions are very chemical specific, and the easier it's find the solutions when the chemical can be easily separated from the washing waters. But that is not always the case. It depends on the chemical properties. But our work still continues. We have some solutions in the case of crude tall oil, but we have still ongoing discussions with a benzene company and some styrene companies. But actually next, Misha, you can talk about your Swedish side, but after that we have Arto Manninen from Bewi Raw to talk about their solutions on styrene emissions. But yeah, Misha, sorry.
Add just a couple of words, because we are really lagging behind, unfortunately. From our side, we have started the cooperation already a year ago, but nevertheless it's been a lot of preparations work, and due to changes in the stuff and all of that, we had some problems, but anyway, we are following the same steps. So looking into the discharge ports or unloading ports and the substances that are more frequently being transported in the Swedish Baltic ports. And actually we came up with very similar list, more or less, addressing the tall oil as the first priority. And it seems that in general in the region we have the growing trend in the volumes of tall oil, perhaps connected to biofuels partly, as I do think that, for example, Preem has for the first time introduced the biodiesel like around 2015, and of course it was in the research even earlier. And now it's not only Preem, it's many other companies that are dealing with this. And secondly, because in general as being a byproduct of the timber industry, and in certain cases pulp and paper. And given also that we have plenty of mills, both in Finland and in Sweden, this is a common byproduct being produced and likewise being shipped. So, and as I said already, it seems that the concentrations of those harbors are mostly in the north, in the Gulf of Bothnia, and as I said, also looking through, well, more or less the same headlines as you had on your slides, with the slicks and spills that were identified. Those were related to ships, for example, that were calling Sandana port close to Gävle, from Härnösand, from Piteå. So all those that are on the, well, all the way north from Gävle and northwards. In Norrbotten and yeah, that area. So in fact, one of the approaches that we were considering is that we should probably address exactly those harbors where those ships called. So having those in mind, that something must be wrong in those terminals, perhaps. And of course addressing the actual receivers of the cargo and the chemical companies that are dealing with this specific cargo. So this is the way that we plan to work with and continue. As I said, unfortunately not as far as you did already, but we are looking forward, and of course we'll be using the examples and also the good practices that being shared within the project already, and it's really good to have already something to start, so it's not from the scratch.
Yeah, yeah.
So
also to encourage maybe other countries to start their voluntary-based work.
It's actually nice to have someone from the terminal who deals with these products also.
Yeah.
So that's what I can complement with.
Yes, thank you. Any questions? Or do we is Arto on the line?
Yes, I am.
Yes, great.
We have a question, I think.
Sorry, one question, Arto.
Yeah, but it was very interesting, of course. But as you said before, it would be very interesting to hear from the cargo owners, from the industry. How can it be like this? Because, as I said before, they were surprised, but they must be able to know it now, because it has been going on since ever.
Yes.
Okay, in a few words, I'm representing the terminal which is a palm oil-based terminal. Usually we follow the rules, and we ask the ships follow the rules. The ships we are accepting in our terminals is from the big companies. This is a Shell company, this is Stena company. They have their reputation, they care about it. So usually they claim, and we accept that everything is okay. But sometimes we receive calls from the neighbors who lives near the port, and they say, okay, our seals are eating something today. Yeah, they are fat because they eat oils. So what do you do in your terminal? This is like not a common practice, but sometimes yes, okay, we know exactly what happens. But from the legal point of view, okay, this is a challenge. So when at the year 2021 and 22nd, we accepted the rules. Okay, we need the port reception facility. We build it. We did agreements. We have the port reception facility who is open to receive wastes from pre-wash. And they are open to take also washing waters, because they have a biodiesel plant, and this is money. Yeah, what you show on the trace, this is really money. And we set set it up, everything. So we have the biodiesel plant who is ready, we have trucks, we have everything. But when the ship comes from the Sweden or Germany, they always have a paper. We have exemption. And we don't have a right to say that this exemption maybe will not be covered at the end of the final place where you will discharge. So they have a paper, we have exemption, and this is what is written in MARPOL. They have exemption. So our port reception facility basically on a normal basis is empty. Yeah, that's the story. Yeah.
Good to hear the real practical example and a little bit of an explanation how you deal. We will continue with that more, I think, tomorrow on the national practices. But now we will have Bewi Raw Oy, Arto Manninen, the production director, who will present the business case that they dealt with on how to deal with the discharges. So Arto, you are with us?
Yes, thank you. So yeah, my name is Arto Manninen and I work as a production director here in Bewi Raw Porvoo plant. And yes, thank you. So in this nice picture, there is our production plant, and in the background you can see the beautiful Gulf of Finland, Baltic Sea. So we are located very close to sea, and I have a few slides from the company I represent, and then the business case itself. So first few words from the Bewi, and then we will go for the case itself. So next slide, please. Yes. So Bewi is the largest vertically integrated EPS producer in Europe. So EPS is expandable polystyrene. So basically the most familiar product in our company is the fish box, so which are produced mainly in Norway, and also the other insulation products. And we have around 80 facilities from the northern part of Norway all the way to southern part of Portugal, and almost 4,000 employees. So this is quite huge company. Where our owner has been very active in acquiring new business. So and our plant is part of the Bewi family. And in the next slide we can see. So yes, so Porvoo plant is located in southern part of the Finland in Kilpilahti industrial area. Kilpilahti industrial area is the largest industrial area in the Nordic countries, and we are representing the raw division. So we have 3 plants in raw division in Finland. Our plant, then one in Wismar, Germany, and one in Etelö in the Netherlands. And these 3 plants are producing the raw materials for the so-called downstream plants. So we are not making the fish boxes here in Porvoo. We make the raw material and we ship the material in Norway, for example, and our downstream is producing the fish boxes. But few words from Porvoo. So our plant was started in 1972, so more than 40 years ago. We have around 85 employees here, and we produce around 110 KT annual here. During this year, it will be slightly less because of the market, but somewhere around 100 KTs. We are producing the EPS in 2 different processes, in suspension with reactors and in the extruder. So that's very shortly about the business. Then in the next slide, I have one example from the environmental point of view, what we are already now doing. This is not the business case yet, but one example how we can recycle our material. So we will start the process not from the number 1, we will start it from here, Porvoo, so from number 3. So basically we produce the raw material here in Porvoo. Then we ship the material to Frøya, Norway in this example. So we deliver the material to number 1, so to the west coast of Norway. And in the fish box plant, they produce the fish boxes, and then the fish boxes are naturally filled with the salmon, and then the boxes with the salmon are shipped to the Poland, where they handle the fishes, and there is a lot of empty fish boxes available then. So in this case, it's written that 5 million fish boxes are delivered to this MARPOL company, which is owned partly by Bewi. In Poland, they clean the fish boxes, they compress it, and they run the material through the extruder, and they get out small plastic pellets, and these pellets or granulates are shipped back to Porvoo, and we can use this material as a raw material in our extruder process, and we can produce EPS again with the same material basically. We cannot make again fish boxes because we cannot use the recycled content material with the food contact, but we can use the material for insulation, for example. So it's 100% recycled material, and this is something what we are very proud of. We have been doing this in Porvoo since 2016, and now we have a new extruder in Etelö, and we can recycle even more. And yeah, that's one nice case from us. But then we can go for the case itself. So next slide, please. Yes, another nice picture from Kilpilahti area. So in this picture, we are our plant is in the left-hand side of the picture in the middle, and the rest of the area is the Kilpilahti industrial area. So we are a very small player in this area, but yeah, still doing good business, I would say. And yeah, the handling method for tank washing waters containing styrene, and this is the Bewi way how we do it. And the jetty or port where the styrene vessel arrives is in the left corner, down corner, and there is the place where the process starts. But the next slide, please. Okay, so the process itself is very simple. We all know that we Finns are simple, so the process must be simple. So basically, you can see the whole process in this one picture, and yeah, we have been doing this already almost for 40 years, so this is nothing new for us. The majority of the equipment needed was built already 1985, so the investment can last very long. So that shouldn't be the issue. But we can imagine that now the styrene itself is unloaded to our tanks, and the next step is that the styrene vessel staff washes the styrene tanks in the vessel, and then the washing water is pumped into this tank wagon on the right-hand side of the picture. So basically we transfer this empty tank wagon to the jetty, and after the unloading the ship, they clean the tanks in the vessel, and the washing water is pumped into this tank wagon. And usually there is around 20 tons of water containing styrene after the washing, and it's usually 500 kilos all the way to 5 tons of styrene in one case. And then the tank wagon is transferred to this location where it is now in this picture, and then we pump the water containing styrene with this red hose to this gray tank at the background. So that's the first part in our area of what is done. And the next slide, please. Yes, and the process is based on the density. So the density of the styrene is lower than in water. So after I would say 1.5 to 2 days, the styrene phase is on top of the tank and the water is on the bottom of the tank. And the next step is that the water is in the tank is drained through the density meter into the buffer pool, which is in our wastewater plant. So in this picture, the tank on the top of the picture is the tank, the gray tank, and the pool under the tank is part of our wastewater treatment plant, and we are using this same pool for the processed water from our production process. So we empty the tank, and when the density of the water decreases, the automatic valve closes, and we have the styrene left in this tank. So basically we drain the water out from the tank, and the styrene remains in the tank. And the wastewater containing styrene is mixed with our process water, and it is cleaned in our biological cleaning process in our wastewater treatment plant. And next slide, please. Okay, and now we have the styrene left in this gray tank, and we drain the styrene in these IBC containers, and we can use the styrene as a raw material in our manufacturing process. So it suits perfectly for our use in this case. Usually it's pure enough, and there is no other substances in it. We analyze it in each and every time, but usually it always passes our criteria. And We have an annual permit limit, environmental permit limit for the styrene emission, what we can have in our waste water, which we pump back to sea after our treatment plant. And our environmental permit is 100 kilos. And we are analyzing the water 3 times a week, and our realized emission is usually around 10 kilos per year. And we process the washing water of about 25 styrene vessels every year, meaning we get around 500 tons of washing water, which includes around 25 tons of styrene. So I have a few examples when we have had almost 10 tons in one load of these washing waters, but in that case I think something went wrong with the unloading of the styrene vessel, but usually it's around 500 kilos per one styrene vessel what we can get back. And this 25 tons of styrene in annual basis, it means around 40,000 euros. So if you are not interested about the environment, you can always be interested about the euros. So and it's even more after we have produced our end product from it. But of course, the reputation of chemical industry and plastic industry, it's not the best one, and it causes gray hairs. Not for me, but maybe for some others in this business. But it's at the same time our responsibility to get the better reputation in future. And I think this is one of the examples from our industry that we are at least trying to do something. And for me, it's nice and easy to be in webinars like this, because we are, I would say, slightly ahead of the regulations. So yeah, that's all. Any questions?
Very much, Arto. I'm sure that there might be some questions from the audience. Yep.
Thank you very much, and thank you for the good presentation. And the question is actually mainly for Jyrki or Matthias, probably, because I was just wondering what category does styrene belong to, just to put it into context, like what the requirements are.
Yeah, it's category Y products.
Immediately thinking about a completely different thing, not exactly about the tank washing, but EPS, that is also addressed in HELCOM context, but from a different angle, especially in relation to marine litter and spills of granules. But this is a completely different story, Arto. I will not ask anything about that, but yep, I think that Fredrik has a question.
Yeah, thanks, Arto, for a nice presentation. I was wondering, so the business case here is, of course, that you can use this tank washing styrene in your processes, and that is, but the ship is delivering the styrene for you, and then they have wash water, and then you, as a service, handle this wash water. But I mean, isn't it the case that the ship could have been obliged to deliver this wash water somewhere else? So is it actually in two processes here? You take care of the wash water for the ship, or are you obliged to do that as a cargo owner? And the second part is that you can reuse the washed or handled styrene in your processes. Can you just elaborate a little bit of this for me as not an expert in this case? Thank you.
Yeah, in our case, it's based on voluntary, so it's not mandatory, but I think it will be someday, hopefully. So we are doing it because we want to do it. So yeah, and we are not doing it just by us. We get the service from Neste Harbor personnel, so they are very, especially during winter, because water and low temperature is always a challenge. So we get good service, and we do it in good cooperation with the harbor personnel. But this is volunteer business, and of course there are these euros behind, but also the environment is the key. So, and this is something what we really want to do. This is for our whole personnel. This is very, very important, and we are proud of this. So.
Arto, I think that was amazing, actually, that you are saving 25 tons per year, 25 tons of styrene per year. So doing it voluntary, you also save quite a lot of resources, I believe. And besides, of course, providing the value for saving the nature. But
yeah, I just had a question regarding the investment that's needed for this, because I was thinking that, I mean, if you've done this in 85 and you save 40,000 a year, then in principle, I mean, it must, how quickly does it pay itself back, the investment that you make in the initial phase?
I don't have a clue how much this kind of equipment costs if we do it today, but for sure this has been, investment has paid itself for tens of times already during the years. So, but I maybe 100,000 euros plus something would be the cost today.
Thank you for this as well, and thank you actually, Arto, for pointing to the temperature limit and limitations in the north, which is important, I think, conditions to remember for all of us, also for, well, any kind of pre-wash and tank washing procedures to be applied. Well, we are living in the northern Europe, and the more harbors with chemical cargo are located in the north of the region. So any more questions from anyone from offline or online audience? If not, and I actually see that we are actually more now online than we were earlier, which is great. And I'm very happy about that, and grateful for all of you participating. But if there are no further questions, yes, Jyrki? Yes?
Thanks so much. Yeah, thanks, Arto, for this excellent presentation that I know already. And I think this is just, I would like to ask the same question than Sonia. Sonia, that this is example that it's some kind of win-win situation for that, and I think that there are also some other cargoes. Can you guess that what are these other substances that we can use the same system for that phase extraction system? That's one thing. Thanks.
I think there is some echo. Yes, thank you. So I'm not expert, but I think it will work in any case if there's a difference in density. So basically, if there's different layers, you can separate the water from the chemical itself. So as I said, it's very simple, and in my presentation you can share it. So there's basically the drawing already. So if someone wants to copy paste the process, you can do it, and if someone wants to visit and see it by him or herself, just call and we can arrange that. So there is not business secrets in this one.
Then thank you, Arto, once again. And I think we would need to compile this type of stories and examples and cases, because I'm quite sure that there are more around the Baltic Sea, and well, we know about some and about specific cargo already, and we will talk more about that later and within our project as well. Yeah, I think it is a good thing to compile some kind of a catalog of those measures. And maybe, Matthias, if you know of any good examples that you can also advise, I don't know, in Germany or wherever else, you're mostly welcome also to share that as well. But meanwhile, we are done with our program for today, at least the formal program. We will have also an informal one starting at 6. And for that, I will let Julia say a few words later on a bit. But I just wanted to quickly, or rather quickly, wrap up about what we did today. So we had quite a big block of setting the scene, and I'm very happy about that, because it allowed us to be on the same page, both with regards to HELCOM and current developments there in the Baltic Sea Action Plan, and addressing specific action that we will talk in more detail tomorrow as 16. It was really great to have you, Matthias, presenting the current regulation about tank washing and the situation in MARPOL and GSAMP procedure. I do recall also some ecotoxicology from my studies long ago. Certainly it was nice to have technology developments discussed and presented, as well as risk assessment. And thanks goes to Anna regarding tank cleaning and the impact on marine environment, and the risk assessment methodology being used so far in the study that was carried out in Sweden. Yeah, another enlightening presentation. Thanks again, Erik, for providing us with some, well, harsh truth, I would say, about how it looks at the sea. And why we actually need to work more on how to deal with reducing those discharges, and well, through voluntary measures, or not necessarily only voluntary measures, also following the legal requirements, and perhaps thinking about how those legal requirements can be adjusted, taking into account also Baltic Sea sensitivity. And then we had the last block about the practical examples and cooperation with chemical industry, and I think it is just the first step, so it is an opening for broader cooperation. So actually I think both John Nurminen Foundation and us at CCB, we would be very happy if more industries from more countries would join, and we are happy to share the experiences and best examples compiled so far. Yes, I think that was it from wrapping up and conclusions so far, unless you have anything that you wish to add. Otherwise, then I will pass to Julia to inform about the next stage.
Yeah,